Howdy, folks. How's it going? Rosendo from MLH here. We are really excited to be kicking off Global Hack Week open source with an amazing workshop from a great sponsor of ours, DigitalOcean. As you may know, they are also sponsoring and working on Hacktoberfest as we speak. So that is actually ongoing, and Global Hack Week open source is a part of Hacktoberfest. So definitely, if you're into open source, if you're into doing technology related things, obviously this is the right place for you. Definitely hit us up in the chat. Let us know where you're joining from. Let us know what you're interested in. And if you have not yet done so, make sure you register at the link right there at the bottom of the screen. It's going to be mlh.link, JHWOS24-DigitalOcean-Workshop 1. We're going to be learning about containerized RAG pipelines today. So if that's something you're unfamiliar with, definitely stick around because you're going to learn so much. We've got a great presenter with us today. And without any further ado, I'm actually going to bring them up on stage so they can get started with the workshop. And I just want to, let y'all know, definitely drop your questions into the chat. We're going to be stopping at the end of the session. We're going to have a question and answer session. So any questions you have, definitely make sure you drop them in there. I will be dropping the link in the chat. But before I do that, let's give a warm welcome to Narsi from DigitalOcean.
Hi, Rosendo. Thank you so much. Hi, everybody. My name is Narsima Badrinath, and I think, Narsi is best suited to call me very short and quick. So thank you so much for this. I'm a senior developer advocate at DigitalOcean. And yes, today I'll be covering about containerizing the RAG applications. So if it is a little advanced topic, just let me know in the comments. I also see we're going to start with the basics, and we're going to come to the RAG and then come to the containerization of the RAG applications. So I think that way we're going to cover a little bit of a basics to a little bit of an intermediate kind of the complexity. All right. So the large language models, I think it has almost become what we are already seeing in our current day-to-day basis. It has become like really important part of our work. So I think I'm using it every day. I'm sure that probably rest of you also are using it every day. So there were actually few limitations before when it started. So before coming to RAG, let's see that what was it actually providing. So if you see that if you use the models, then if you ask any of the questions which are, let's say, happening very recently, or let's say today, if something had happened, then you wouldn't get the answer as to, okay, you know what, the recent information is not available in the models because it was trained on the data that was available as of a particular date. So because of that reason, you might find it stale. So another very important point is that the context window. You might have heard about this as what is the context window. So there is only so much information that we can provide to the model when we are prompting the models. Let's say you ask a question and you actually give some information to that model saying that this is the information that you can use to answer me. So then there was another challenge with respect to the context window, because let's say if I have a use case of getting the Olympics medals, how many of the medals that we have got, let's say a particular country, US, if I give that information into the model's prompt and I say that, okay, these are the medals which are procured by these many countries, and now tell me out of this one, which US is how much and then China is how much and things like that. The information, let's say if it is only for today's or this year's, then you know that the model can actually tell you because it has that information in the prompt itself and only limited information, so it is able to answer. But let's say if I want, actually the requirement that I have is that I need this model to answer me if about everything that has happened so far with the Olympics, every year details, how many medals has been won by each of the countries. That is huge information. So in that case, it is not, I mean, the model might know till only the last year, but this year's probably it is not aware of, but I still want this information in as well, along with what has been already trained on. So that becomes a little bit of a complex thing. So that's where the technique, I mean, it's a genius technique actually to figure out that, okay, what if we fetch that information from external source and give that as a context to the models. So that, in a way, we converted that limitation of the models to an advantage to us by providing the information which is available outside. It could be anywhere. It could be available in some websites. It could be in some databases. It could be anywhere. But just by fetching that information from any of these external sources, by providing that relevant information to the model, and if I say that, okay, now you know this information, tell me, so how many of the medals are won by US or China? So in that case, I do have a lot of information available from the external sources. Let's say I could do an API call and anything, and then I can fetch only that information which is relevant, and I can give it to this, and then I can tell that, okay, you know what, based on the user's query, so the information that is available, based on the user query, fetch only those things that are relevant to the question, and then give that to the context, and then model will do a better job. So that's what is happening as part of retrieval augmented generation. So if you have, I'm sure that most of you have heard about it, you might have even implemented it, but I think this is a very simple implementation just to go through, so that we can actually see that how the code implementation looks like. And then that code implementation is also very simple. And then we're going to look at how to containerize it. We're going to come to the containerization as to why we need to containerize the RAG applications and what advantages that we get for by doing containerization of these applications. So to start with, the implementation of the simple RAG in itself is going to start with, let's say, a doc retrieval and ingestion. So as I said, so let's say the use cases, I mean, if you look at this idea, then actually it can be implemented almost anywhere where a user wants information and that information is present somewhere. So this can be combined. So the information is present somewhere. Let's make sure that it is available in one of our databases. When user asks question, let's provide that relevant information to the user. The user gets the information. Amazing. So wherever this kind of a use case is there, almost everywhere this can be implemented. So that's such a powerful technique. Because of that, you can see that in most of the AI applications that are currently being implemented, this actually is the major, it takes the major portion of that share. So it starts with the document retrieval and ingestion. So let's say I want a conversational bot. Let's say I actually have my company's information or my product's information, which the users should be able to get access to. In that case, I can put all the products related details. Let's say if I have that in the PDF format, Word document, or any kind of a format, so I can just make sure that this knowledge base is that I'll just make sure that those documents are that those information is given through the embedding model. Embedding model actually makes sure that all this information is converted into a number format. The ML models, these models are actually good at only the numbers, right? Because they compare the numbers and they know that, okay, which is more similar to what. That's what these models are really good at. So because of that, actually, the keyword comparison, what we used to do before, let's say if I search something which is keyword matching, it actually changes that the game very differently to semantic search. Let's say the keyword matches the exact word, but in our case, in this particular case, it does a semantic search. So the semantic search is more of, okay, so it tries to understand what the user is wanting from the question. So if I ask a question, it tries to understand the semantics of it, tries to understand the intent of the question. Accordingly, it will try to understand that in the vector DB, where is that relevant information that is matching to the user's query, and then it will fetch those things and it will provide back to the user. That's why this is actually super powerful. So those documents are embedded in the vector database. So unlike the traditional databases, this actually is stored in the vector format. So even retrieval will be in the vector format, but when it comes back to you, it will be in the text format itself. You can use any of the vector databases for this. There are like many like to Postgres, ChromaDB, Milvus. Any of these can be used in memory, and the SaaS solutions, many combinations are available. But ultimately, the data that we want, let's say I as a person who owns a product, all the information that I want to provide in terms of PDFs, documents, everything, I'll make sure that that goes into the vector DB. That's the thing that has to be done first. Now, the next part is that whenever there is a query from the user, which is from here, then it will be made available. The query will be made available via a chat bot, or it will be a very simple interface wherein a question or text box is there, and there is a next text box will give you the answer, or a very good chat experience. It could be, however, the way we can actually come up with this UI for this. The user query is again going to be embedded just like how we have done the documents. Then the user's query along with uh, the prompt. So we will have a prompt saying that, you know what, so based on the thing what we are building, let's say if it is a customer service agent, then we actually construct the prompt saying that you are a customer support representative and you are good at so and so, and this is the context for you, which is actually retrieved from the vector database based on the question that is given by the user. Then we'll also give the question to the question in the prompt saying that LLM, so this is what I want you to do. So the models, the LLMs are really good at, okay, I have been given this as an instruction. I have been given this as a context that, okay, the relevant things that are, this is the context on which I have to look for as the answer to the user's query. And the question is the user's question. So with these three things, the models are really, really good at generating responses. So the decoder models are amazing at coming up with responses with this instruction, the context, and the question. So that's what makes the whole RAG implementation great. So that's why you can see that in many, many implementations, this has become very, very common. So how do we know that so let me switch to yeah, so the code walkthrough. So let me go to the VS code. Yeah. So you can actually implement this in a very, very simple way. If you just ask one of the LLM, let's say ChatGPT or Gemini or any of these models directly, said, give me an implementation of RAG, then you will actually get a very simple implementation of how to do retrieval augmented generation. It will tell you that what are things to use and everything. If you run it, it actually works. So the question is, okay, now how are you going to take it further? So that is the productionizing part of it. But before that, we're going to break it down into three things. The thing that we saw in the diagram, how can we actually implement it? So you can write it in 10 lines also. You can actually break it down into much more modular also. In this case, you'll see a little bit of a modular approach. So the modular approach is that you can actually see that it is divided into web application, a store service, and a Chroma database itself. So this, it can be understood even in better via a diagram. Let me actually pull up this repository. So this is the code base, and actually this is a diagram probably with which we can understand this much better. So the thing what we saw in the blog, the diagram itself, if we want to implement in a code format, so it looks something like this is the UI. This is the web application, which contains a Gradio application or a Streamlit application or any kind of an application for that matter. This is a one component. And the second component, we can consider the vector database itself. Again, it could be a ChromaDB, Postgres, or any of these things. The third one, we can separate it as a storage document or store service or anything that we can call it. So in this particular service or in this particular component, what we can do is that actually we can just pull the information that on which I have to query. So in this particular case, actually, I have a few PDF documents which I have already uploaded. So in this particular code, I'm going to pull that PDFs from the external source, and then I'm going to ingest, or I'm going to push that into a vector database. So there could be multiple ways I can do that. I can chunk that information into smaller paragraphs. So actually that makes it even better for retrieving. So there are multiple techniques that we can use. So because of that, let's say if I want to change that technique in the future, or let's say if I want to change the vector database itself in the future, because I found out that there is an amazing another vector database out there which is like giving amazing performance. So probably let's say if I want to do that in the future, so in that case, I think componentization of these things gives much better advantage. Also, why? Because we can containerize it and we can just run it. So I'll come to the containerization, but this is the way we can even see it in the code itself, the web app, the store service, and the scripts. So here we can just see it better in the VS code. So the web application is the UI, as I mentioned. You can see that The web app contains a very simple code. So this contains the Gradio interface, which contains a single row and one text box. I'll show the UI after a few minutes. It just contains one text box and another answer. This is a question, other one is the answer. And when the submit button is clicked, I'm just calling the get answer. And this get answer is actually calling RAG, which actually is responsible for getting me an answer to the question user is asking. And that is present here. So here again, as I mentioned, we are going to form the prompt in a way that will instruct the model that you are so and so, and we will give the context saying that, you know what, for the user's question, this is something which I retrieved. So where do we get the retrieval? This is the retrieval. We will go to that the moment we finish this one. So the
Darcy,
context is
sorry.
given from the retriever. Hey, yeah.
Sorry to interrupt. Could you just zoom in on the
Uh,
VS Code a little bit?
let
Just
me
for the
do.
folks at home,
Is
I
that?
appreciate it. A little bit
Yep.
more.
Yep.
There you go. Thank you so much.
No problem. Okay.
All right, y'all, back to our
So
regular scheduled program.
perfect. All right. So this is the simplest implementation. You actually can have various different varieties of the RAG implementation itself. This is one of the implementations. So the context we can actually provide saying that, okay, here is the context. This is the instruction, and here is the question from the user. And this can be given to a chain. So LangChain is one of like really amazing tool you can use, a framework you can use for chaining multiple things. In this case, I have actually chained the prompt and then which model it has to go to, and then finally how the output should be available to me. So this will make sure that the prompt is generated and given to the model will execute it and given to the output parser. Finally, I'll get a response. That get response will actually give it back to the text box in the Gradio. But the missing piece is the retriever. So this is what is in the retrieve documents. So here is where we are using the Chroma DB, which is already having the data, which when the store service runs, I'm going to come to that, it would have already stored the vectorized format of the PDFs, everything into the Chroma database. So all I'm going to do is that say that, okay, this is the collection which I have the information stored, and then retrieve based on the question that user gives. So here is where I can say that what kind of search type and all these parameters. So which actually gives me that the relevant documents based on the user's question from the vector database to the model, and then the model will takes care of the context is aware of, and then the question it knows and the instruction it knows, and then it will tell you the answer. So this is the website or the web part of it. So the storage is the second component that I talked about, is having this store documents, which actually does very simple things. So in this particular case, I have stored as I already mentioned, we can actually pull the data from multiple sources, right? Based on how I have actually stored my information in different formats. So LangChain itself provides multiple adapters. Your information could be present in database, it could be in a URL in one of the websites that you have, or it could be the PDFs or Word document or Notion database or anything for that matter. So you can just have these adapters, you can just use it to pull that information, and then you can just upsert that data onto the Chroma database. So this does that particular logic. So by separating this as another component, what are we trying to achieve? Let's say if I want to introduce another source in the future, so I can just come here and add that particular extra function or probably another module to this, so that I extend the functionality also by providing that in the storage service. Or if I want to change the technique, I want to use some other embedding model as the chunk size, or you can see that there are so many things that we can actually modify to change the strategy itself as to how we are storing the documents. So if it ever comes to that, again, it is going to be very much easier. So that why? Because we have isolated this as a separate component itself. So the web has taken care of the web side of it. So the storage is taking care of how to store the information. ChromaDB is going to run separately as a standalone application or standalone container when we actually run it. So this is the containerization of the RAG application itself. If you see the simple RAG implementation, implementation from LLM or any of the things, you might get everything in a single .py file. But we have separated that in this format because we get the advantage of the flexibility. And the next important thing is the scalability. So how scalability, let's say currently I am having very few users, but let's say it increases to hundreds of thousands of users, then probably I might have to move this to, let's say I should make this application to be available in multiple uh, uh, like probably behind a load balancer, I should be deploying this to multiple servers. In that case, containerizing this application gets a really advantage because we can easily deploy this to Kubernetes. And we all know that how Kubernetes can handle that kind of a load. So that's the biggest advantage of first, the simple RAG application itself, how that can be converted into this multiple components. And then the comes to the part where how are we gonna containerize it. So this part maybe requires a little bit of a Docker knowledge or containerization knowledge. I'll try to if you have that knowledge, probably you'll understand it very easily. If you don't, also I'll try to make it easier so that you know what actually is happening in this compose.yaml. So Docker Compose is one of the ways we can actually spin up multiple containers. So one container for us is just one of the component. Let's say ChromaDB is one component. It runs as a database. Store service is another component. When I run it, it runs. And third component is the web application itself. So when I run it, it runs as a web application. So I want all the three applications to be up and running because these three talk to each other to give me a feeling that it is all single application, but just making sure that it is serving the purpose. How are we going to achieve is just by using this one Docker compose.yaml. So the ChromaDB here is one I already mentioned, talked about in the diagram, and second one is store documents, third is the web application. This exact implementation is what we saw in the diagram, how we have even bifurcated or divided that into containers also here. So the ChromaDB is very simple. Here we are just downloading this image, which is already available in the Docker Hub, and we are exposing that in 8000 port, and we have volume mounted so that let's say even if the ChromaDB goes down for some reason, it is still storing all the data that has been vectorized by us in a host machine, so that I can just spin up the ChromaDB again and the data is pulled from the same location. I am not at a loss. So that is the advantage of just mounting, and you can see this mount used in the other containers so that these other applications will refer to the place for getting the information. So that's the ChromaDB, but the store documents and the web requires us to build the application. So that's why you see that build, wherein we are saying that where to look for the code, it is present in the storage service. And then you are saying that run this Python code, store documents.py. When this Python code is run, then basically, as I said, it is going to pull the data from the external sources where I have mentioned. In this particular case, I have stored my data in the DigitalOcean's object storage. So just to give you as to what and how it looks like. So you can see that this is the spaces object storage, and I have called this as AML bootstrapper assets. So I am actually going to show a very simple demonstration of the GPU droplets, which is the new virtual machines that we have, which are backed by GPUs, H100 GPUs. So these three documents contains a little more information about what are those GPU droplets, what is it used for, and things like that. So let's say if I have any questions as a user, which those documents contain the answer, then I can just query about it. And this model via the RAG approach, it will find the relevant documents from here. It will give me the answer. That's what we are trying to achieve. So I have already uploaded these PDFs. So what's happening here is that when this store documents is run, this code is basically pulling that information, downloads files from the DO spaces. So I do have some of the config values that I have to provide so that this code can talk to the object storage, pull the details, store it in one of the folders, and then make it available for the model to retrieve it. So that's what is happening as part of this one. So once this is done, that means that we already have the ChromaDB running. The second part, when the store documents runs, that means it has pulled the PDFs from the object storage. It has stored into one of the PDFs folder within the container. It has also pushed that to the Chroma database. That Chroma database has vectorized it and stored it in a volume mounted in a host machine. It is available in the host machine. So this is the second thing which has completed. When it runs, it would have completed the second big part of the whole solution. Third part is about running the front end, which is the web application. So where to look for that is web app. We can just mention that look for this Docker file to build your image. And then we say that it depends on the store documents, because store documents has to already do its job in order for the front end to work. So that's why we say it is dependent. And finally, we say that run it on 7860 port. We are also mentioning a network that so that all three should actually connect to each other and talk to each other. That's why we have built a network. So secrets is the one which I have already told in the store documents. It uses what is the secret key and which is the endpoint to talk to in the new object storage. So we can all mention that in a simple config file from where it can read and it can execute the store documents Python file. So this is the containerization of the RAG application. It actually might look a little complex, but it is not. So it is just a one-time job. You just have to divide that into these three formats, and if you just run it, then actually it runs as containers. So you can see that once it actually runs as containers, so Docker ps minus a, if you run this, then each one actually will run. So this is the web application, this is the storage, and ChromaDB is the database. So if you see, Chroma is still running, and this storage store documents has run and it has exited also. That means it has exited running the store documents.py. That means it has done the job of pulling the PDFs, vectorizing it. ChromaDB has the information. Web application is ready to take on any questions from the user. So we are good till here. So now let's see that how actually this can be deployed. So for that, so we can just go to the README. We have just updated this information. You can see that if we want to deploy this, so now that means our code is ready, right? So we have taken a simple RAG application and we have modularized it. And how we have modularized it is so that it can be containerized very easily. And how are we going to deploy this? Where we are going to deploy is the next part, because it has to work and we should be able to access it. So this is it. It takes the route of deploying to GPU droplets, which I talked about. So if you see the GPU droplets, I mean the GPUs is very important for this, because we are in this particular case, if you have observed, we are using Mistral as the just yeah, let me expand that. So you might have seen that. So we're using Mistral as the model, which actually loads, and then it'll actually ensure that the questions are answered by the Mistral model. So because of that, the GPUs are very important, and that makes the job much easier and faster. So that's the reason why we're going to use GPU droplets. So we're going to use it in DigitalOcean. So you can use, if you don't have the DigitalOcean account, you can just click this URL, create one. And there are two ways you can just create the GPU droplets. One, I have already done it via the UI by just clicking on this one and filling some of the details here, the region and the image and things like that. You can just click create GPU droplet. That is one of the ways to do it. The other way to do it is via the doctl command. So doctl is the CLI, which actually helps you to fill up some of the parameters. If you can see here, then it asks the name of the droplet, the region, the same things, almost everything that we provide in the UI can be just provided as the parameters here. I prefer this way because I can just keep it ready and just run it. If I want more droplets, I can just copy paste, just change the name, and it just is much, much faster. So by doing this, we would create a new GPU droplet. In my case, I have already created, that is the one which I'm using. But by running this, you're going to get a new GPU droplet on which, so the next part is going to be how are we going to run this? So you can clone this repository inside the GPU droplet. Basically, that is just another virtual machine which is backed by H100 GPUs. So we are going to do SSH onto the machine. So SSH root. The moment you get the IP address from there, you can just give this. There are multiple ways you can just do SSH. You can use Max Terminal, or in this way, if you have observed, I used VS Code's remote extension, you can install remote SSH extension in the VS Code, which allows you to connect to the host and even open the files, and allows you to execute any commands on the terminal. So that's much easier. So basically, you can do SSH onto the machine. Once you have done the SSH, you actually have the terminal where you have access to the machine. In this case, we're going to do a git clone, and we're going to move to the RAG containers folder. And then this is the file I was talking about, where we mention the DO spaces configuration that, okay, I need, in this particular case, my external source is a DO spaces object storage. I have put my PDFs file there. By providing this values, I'm going to ensure that the store documents is going to make a call to the object storage, pull the PDFs, and then it will execute the rest of the stuff. So this is the only thing that you have to update, so that you can just get the external source information. You can even extend, as I said, the middle component to pull from the URL or database. That can anything be done. This is a very simple example where we are just pulling the data from the object storage, and it's going to be the PDFs. So finally, we're going to come to just running the application, where we have already given run.sh. When you run this, it will basically execute Docker Compose, which is this. The Docker Compose will in turn run all the three containers. It is going to take some time. So when it executes, then it will actually do a lot of things. You have seen this. It has to run the ChromaDB container. It has to build your store documents. It has to build the web application, and it has to actually create an image out of it, both the images, and then it has to spin up the containers, and all the three should be working. That's going to take a little bit of time, but it's just one time thing. So when we run the .run.sh, that is what's going to happen, and that's what you can see here. That means that your application, when you have this, the status like this, that means your application is running, the web application is running, the ChromaDB is running, the store documents has finished its job. How do we access it? So we can just go back to the GPU droplet that we have created. So let's check out. So this is the GPU droplet I have created, and we can see the IP address of this machine here, and we can just copy it. And if you remember that we have actually exposed the web application, the Docker file of the web application is exposed in the application in 7860 port, which is what we have mentioned in the Docker Compose as well. So that means we can access this application in 7860 port, appending to the IP address of the GPU droplet. So this is what I have already opened. So you can see that the same IP address and 7860 port opens up this as the UI of the application. So this is a very simple UI. So as you have seen, that a simple question answer, which we saw in the Gradio interface web.py. So it can be converted into a chatbot, so that you can embed in the website, or we can actually give it like an amazing chat GPT's experience itself as complete web page, where people can just, keep chatting. So that's up to us as to how we want to, make this UI better. But in this case, so I know that, okay, those PDFs contain information about the GPU droplets. I can ask question about the GPU droplet. I'm going to keep it very simple to start with. Let's say, what are GPU droplets? So this is going to give me answer. If you see, it took probably even less than 2 seconds to answer that, because actually the GPUs are super powerful. In this case, it's actually running on H100. So if you go with a lower power GPUs, then it might be a little more time taking. But because it is like GPU droplets H100, the answers are like super fast. And it is actually saying that what are the GPU droplets. And you can even ask more questions like, okay, how does it differ from normal droplets? So again, it'll be able to tell you that in fraction of seconds. So that is like super powerful. So that means that, so this, now we have enabled, so because of the techniques of RAG itself, that means that we have enabled that any kind of a source, let's say external source, I'll be able to fetch the information, vectorize it, store it in the vector DB. The question that I'm giving here is going to be embedded. Again, it is given to the prompt with the context, which I'm going to retrieving from the vector database to see what is relevant to the question that I'm asking, and then the model is going to generate the answers. So because of this, actually the applications are immense. You can see this, as I said, implemented everywhere. So that's what primarily I had in my mind. The last bit was to containerization. That's what is something, it's going to make it even more flexible, to choose, like with minimal changes you'll be able to move to a different vector database or change the strategy of how you're actually storing the documents and things like that. All right, so yeah, I think that's primarily what I had in my mind to cover for this session. So let me see. Yeah, I think I'm good. So Rosendo, let me know if you have any questions. I think I'll be able to take some.
Yeah, for sure. Let's just pop them up onto the screen here. When you were talking about RAG earlier, ZS0707 asked, does ChatGPT do this? Yeah, general question.
Does ChatGPT do this? Okay, so the ChatGPT are, I mean, these other models which are already trained on the data which actually they have used the existing data from the internet and trained it already. So this implementations are about how to use those models and extend the functionality. So this will be applicable where we have to make it even more specific. So you might be seeing the implementation of this in the field of a very, very specific domains or industries. It's legal and finance and things like that. Let's say where the entire data for finance was probably not used for training those models. In that case, if I ask some very advanced questions in those, probably those models will not be able to answer. That is where we can bridge the gap by actually using that information which is available in the internet, or let's say proprietary in some of the organizations. We can use those things and give as a context to these models, and we can enhance the functionality of the existing models. That's where this will be useful. I hope that answers the question.
Awesome. Next question comes from Ashul. 1, 2, 3, 4, 5, 6, 6, 6, 8. How hard is it to integrate APIs with those LLMs that you were discussing earlier?
Yeah, I think it's not that difficult, because I think that's where I think most of the applications currently are heading towards, because LLM's capability is all known that what it is capable of. Now imagine there are there are thousands and probably millions of softwares that are running in this world, and many of them provides APIs. Now you can think that, okay, I can just call this API from one of the software, I can get the response, let's say a JSON format. Now I can make the call to my LLM, get this response. I can make another call to another API, get the response, or pass the output of this to the next one. This is where actually we are all heading towards, where how many things can be integrated together and achieve some things which were not, automatable before. So now it is going to move towards, I think you might have all heard about the agents. So we're going to move towards that, wherein it will even have the intelligence built in, so that some things what we actually thought were like possible in dreams probably is possible now.
Awesome. Alrighty. Let's hide that one. The next question comes from Jisanar. Can you please explain which type of data we should embed in a vector database for the best results and why? And just a
Yeah.
follow-up question is like, what format is best?
I think at least the examples which I have seen, the most of the implementations of this, the textual format is what has been the easiest and the best used, because the adapters that probably you might have already seen, if the lang chains or any other adapters, are great at uh, the docx's, PDFs, and these kind of ones, which actually gets you the text or extract the text out of it, and so that it's easily, probably we can just vectorize it. But yeah, the other kinds are also possible, but I think the best result probably is for the text, is what from my prior experience also. Yeah.
Gotcha. So text, yeah, I had responded and mentioned something about vector databases being really good for high dimensional data. The follow up
Mhm.
question is yeah, he works with vector databases, read a few articles on vector databases. Sometimes you have data with a lot of different variables in it, and sometimes you ask for them to retrieve like some of the
Yeah.
like highest level of like I guess data saturation there, and it's not always correct. So I guess that was the follow up question here on screen.
Okay, okay. It's what it is. 10 best items the user asked. Okay, is not always correct. Yeah, so that's true. So the implementation probably what I showed does not cover as to the top K and probably the other parameters that we can provide for the retrievers. So you can actually do a lot of now tweaking there as to how to get the best out of, let's say it retrieved 10, but say out of that how many I have to give to the models. So there itself we can actually play around a lot. So those things are probably the next things that we can actually explore in the RAG itself. It is already being implemented in many of the applications that you see out there. So that is definitely possible. And that makes a lot of difference for sure. Yes, as to out of these I retrieved, yet I probably want to decide like ranking them in terms of what's best to give it to the model before I, just give all of them to that. Or yeah, that definitely is already implemented in many of the applications. You can just explore it. I just haven't covered that part because I just kept the containerization as more of the focus of this talk. Yeah.
Gotcha. TLDR, text is the best for now. And yeah, make sure you rank your data as you're getting it inputted into your model. The next question comes from Kavyasam. Could you please just recap everything that you taught us shortly? Just in, I guess, in a couple of sentences. It's a very open-ended question, I know, but just like I guess like key takeaways that people should be getting from this workshop.
Absolutely. I think I'll try to do best in very short time. So we knew the LLM's limitations that okay, the context window that we can provide is less, but nowadays I think we are moving past that. Also, you might see that the Gemini models are coming up with million tokens, but yeah, at least for the context of what we are talking today, the context window, let's say we'll keep it that there is limitation to that. So, and there are multiple other applications where the RAG can be used, for which definitely it is good if we actually fetch from the external source and provide the context to the model so that we can get best answers for the user's queries. So with that in mind, the RAG actually does much better, and this technique is being applied almost everywhere where there is a question from the user and somebody else has to answer in that scenario. And we are taking that a little step further by making that into multiple components and containerization, so that you give more flexibility and scalability to the RAG applications itself. And that can be done via the way we did the containers, Docker Compose, and then deploy to amazing GPU droplets.
Awesome. And the last question here is coming from Siroso7. I'm an intermediate. I'm building an AI. Is this setup the way to go? So I guess in reference to RAG, just generally speaking.
Yeah, perfect. So yeah, if you are implementing a very simple RAG application, which if we think that in this case is what you are trying to achieve, you can just go ahead with this. You can run this locally without the containers first. I have even given the simple main function so that you can run it separately to test it out. The rag.py itself or the other things to test it out. Then after that, when you know that it is working, you can just containerize it in the local itself. You can use the Docker to containerize it and run it in the local. Once everything is fine, you can just deploy it to one of the virtual machines which are in any of the cloud service provider, GPU droplets also. Yeah.
Awesome. I lied. I know I said that that was the last question. Was the last question at that moment. There are a couple of more questions that just came into chat. So from VRX2314, can RAG be used to personalize responses based on user action history?
Yeah, actually, yes. So it based on what we are capturing in terms of user action history. So if we have that information stored somewhere as to, yeah, user did this, user went to this particular web page and user did this particular action. If it is stored in the format that probably we can just retrieve it, give it to the LLM and then say that, you know what, this is what my user has done and what I want my user to do next. And probably you can just give that in a prompt. It actually, much of the things comes down to the prompt as well. So that can be even explored. There are some really great websites where you can actually check out what are the good prompts for things like these. So then you will be able to definitely do this. So the thing is, first get the data first, and then use that. And then again, relevant, what is relevant to the personalization that you are thinking about, give that to the model, and let the model tell you that, okay, what should be given to the user now, because it knows that information. Yep.
Awesome. The next one is a little bit of a tech stack question. So I'm comes from EvoTech 2022. 22. I'm familiar with JavaScript, FME Workbench, and Postgres. Can I adapt? Are we able to adapt these for a RAG container or to a RAG container?
Yeah, okay, absolutely. Because I think I'm not getting what the FME workbench is, uh, but yeah, considering that, okay, it is JavaScript and Postgres, yes, it's definitely possible. Uh, this is an example of a Python, but yeah, it's definitely possible via by building the JavaScript application. Also, Postgres is an amazing example where you can use it. Postgres has the vector, possibilities, so that we can just vectorize and store it in Postgres. So definitely possible. Containerization doesn't limit, as long as your application is ready, working in local. You can containerize it. You can just deploy it. Yes.
Great. And another one from Ashul. Um, what, according to your knowledge, do you think will be challenging when building voice AI using the LLMs that are currently out there?
I'm trying to understand. So the challenging when building voice AI using LLMs. I think with a particular use case, I think we'll be able to understand this better. But the challenge probably, I'm trying to understand one of the use case in my mind. I'm trying to answer that. So in that case, it would be like you will have to first transcribe. Let's say if I'm saying something, you will have to use one of the models to transcribe that and get the text and see that what actually user wants, provide that to the LLM and get the response as to what the response has to be. Then again use that text to convert that to a voice, and then say it back to the user. I'm just assuming that is one of the use cases that probably you're thinking. There is no challenge to this. It's the models are already available and everything is possible. So probably you can just give a better, you can rephrase it to give it to one of the LLMs, and you will get the entire code for getting the whole thing done.
Amazing.
Yeah.
All right. Looking through the chat here, it doesn't look like there are many other questions. If y'all have any questions, now is your chance to ask. The one thing I will say here is thank you so much, Narcy, for coming and joining us. This was a great session. If you have any like parting words, feel free to provide them now. Otherwise, I can just kind of I guess get everyone shepherded over to the next piece of content. But it's up to you.
Yeah, absolutely. I mean, it was great. Thank you so much for giving this opportunity. And I think just one thing I want to say is that I think a few years back, what we had as a technology, probably if I think of something to build, I can think of something to build now, because the models and the computer vision models and the language models that are currently available is making that imagination possible. So if you think of building something, it is possible to build that. So it is that kind of an era that we are, because of which I think it's an amazing time to be a developer, startup founder. So I think it's an amazing time. So if you want to build something, if you have that in my mind that you want to build something, it's almost possible to build that. So that's why I think it's a great time. So that's why I would say all the best to everybody who is here, to who is building something great. So thank you so much.
That's amazing. Honestly, couldn't have put it better myself. Definitely a great time to be in tech. Definitely be a great time to be an innovator. So many things possible that weren't possible, like when I was growing up and first learning about software and things of that nature. So, thank you for saying that. I guess from my end, last thing I will say is DigitalOcean is going to be heavily involved in Global Hack Week open source moving forward. So if you want to check out any of the challenges that they currently have available, head over to the link that's down there. I put it in the chat as well. You'll see all of the challenges, the live labs that you can participate in, all of the additional learning resources that are going to be available to you. In addition to that, we will also have another workshop that is dealing with app platform and deploying your applications there tomorrow. So be sure to stick around for that. And last but not least, we do have another workshop happening at 12 p.m. EST today, getting started with Python and Oracle database. So make sure you check that out as well. It's coming right up in the next 11 minutes or so. Once again, Narcy, thank you so much for your time here. Really appreciate having you. And yeah, wonderful time as always. Hope everyone out there had a great time. Make sure to keep it locked. Once again, in the next 10 minutes, you will see the next workshop popping up. All right.
Thank you all. Bye bye.